Hi, I'm Sajid, and I've been working in the field of AI and data science for more than 10 years. I worked in different domains: computer vision, predictive analytics, time series problems, natural language processing, and so on. Besides development, I am also involved in training at different levels. So today, let's start with the difference between logistic regression versus linear regression. So let me open the slide. Uh, so let's start with the linear regression in machine learning. Let's suppose we have a data set of we have a mouse data set and we have two features. The one feature is the size and the other is the weight. Now we can consider one feature as a dependent variable and the other as independent. So we will be using the independent variable, that is weight, to predict the size of a mouse. Now we have this training data. We can see here that we have 5 training samples, right? For each sample, we have weight and size. Now we can fit a line. We can fit a straight line. Now that line can be used for different purpose, but here we are, since we are talking about the linear regression in machine learning, so we are assuming that through this line we can predict the size of a mouse based on the weight, based on the given weight. So once our model is trained on the training data, that trained model can be used to predict the size of the weight, and it will give us a continuous value of the size. By continuous value, I mean that size can be 1.1 unit, it can be 1.0001 unit. So there can be infinite values for the size. Let's say once our model is trained, we have a new mouse and we know the weight of the mouse. So based on the weight of the mouse and based on the training model, we can predict the size of the mouse, right? So let's say we have a weight here of mouse here, then based on the weight and the trained model, we can predict the size of that mouse. Now for multiple regression, in last slides we were talking about a single input and single output, but if we have multiple output and if we have multiple inputs and single output, then that model will be known as a multiple regression model. You can see here that we have two inputs. The one is the blood volume and the other is weight, and we are using these two inputs to predict the size. So this will be the case of multiple regression. So this is the difference, that in normal we just have a single input, while in multiple regression model we have multiple output. We have multiple inputs. We can have 2 or more inputs for multiple linear regression. Now let's talk about the logistic regression. In logistic regression, we predict a class instead of a continuous value. We predict a discrete class. So in this example, we have two classes, whether a mouse is obese or not obese. So we have around, you can see that we have around 5, 6, 7, 8, 9. We have around 9 training samples. And based on those samples, we will train our model. And once our model is trained, we will be able to predict the class of the mouse. So sigmoid is the function which fits for the logistic regression. So instead of a single straight line, we fit a sigmoid function, and the minimum value of a sigmoid function is 0, and it goes up to 1. So let's suppose we have this sample, a new sample, and based on that, based on the train model and the weight, we can predict the size, or we can predict the class of the mouse. So here we can see that it is almost 100% sure the mouse is obese if the weight is this one. So this is another case in which we have an intermediate value for the weight, and here we are 50% sure that the mouse will be obese. Here we can see that we are the probability of being obese is almost 0%. So to summarize the logistic regression, we get a probability for the class, and then based on that probability we can predict the class. Now we can use some threshold value. By default we have a threshold value of 0.5. So if the probability above 0.5, the mouse will be obese, and if it is less than 0.5, it's not obese. So we can set this threshold value. We can try different threshold values. So this is about linear regression and logistic regression. Thank you for your time.